Amber is the most mysterious organic gemstone. It is believed to be fossilized tree resin from the late Cretaceous or Paleogene period. And often, when people talk about amber, they mean Baltic amber. The deposits of Baltic amber are dated to be 37 million years old, or even older. It would seem that in ancient times forests covered more territory and amber should be found almost everywhere, especially where there is a lot of coal and lignite. However, the birthplace of amber is limited to just a few areas on the planet. One of them is the Kaliningrad region. Here, amber is mined in quarries and the fossilized resin is found in these kinds of conditions. Amber is found in sedimentary rocks like sand and clay, but the trees are missing from these soil layers. This is a primary mysterious fact among the already large number of amber's secrets. Not or. There should only be extinct insects and animals in amber, but it turns out that half of the ancient unchanged creatures have survived to this day. The weevil in the photo still exists, as well as the same mosquitoes, flies, and butterflies. And they are also of the same size and shape as their modern counterparts. No giant forms. Paleontologists have described species of arthropods from Baltic amber alone. About 10% of insect and animal species in Baltic amber are from a tropical climate. And this can be considered a fact that there was at least a subtropical climate here. Salpugids are found in amber. They currently inhabit Crimea and Kazakhstan. Ukifrins are inhabitants of the tropics of South America, as well as scorpions and even geckos. Moreover, some of these species cannot survive the winter and are adapted only to a consistently warm climate. Also, mosquitoes and flies are found as inclusions in amber, especially biting midges. Mosquitoes make up to 80% of all inclusions in amber. Beetles with wings, lace wings, mites, termites, caddisflies, ants and wasps, dragonflies, cockroaches, book lice, and others. In one of these pieces of amber, there is a unique specimen, a dinosaur tail, specifically from a species called Coelurosaurus, about the size of a sparrow. Modern species of plants and trees are found in amber. In addition to insects and small animals that still exist today, amber contains remains of sequoia, Scots pine, oak, spruce, alder, poplar, laurel, taxodium, and palm trees, as well as from the cypress family which now grow in the swamps of North America. The main part of the forest consisted of sequoias and agathis. It now grows in Polynesia and Australia. These are all facts that tell us the climate here was much warmer than it is now. And the insects got into Baltic amber quite recently, not millions of years ago. Many of the tree species on this list are not resin producing, yet their leaves and branches ended up in amber. In Baltic amber, up to 98% of all inclusions are insects and small animals, and only 0.5% are plant parts, conifer needles, bits of bark, or seeds. But it should be exactly the opposite. The tree resin should have trapped pieces of the tree that produced the resin, fragments of bark, needles, scales, buds, and seeds. But again, we don't see this. So the question is, what kind of tree was the source of the amber? And there is no answer to which coniferous tree could have been the source of the resin. Paleontologists officially claim that the resin was produced by the Scots pine, but some of the resin could have come from cedar or even from agathis and araucaria. These are tropical conifers. So why conifers? Well, at least because if you actually burn amber, you'll smell the scent of burning conifer resin. But here's the question, could the Scots pine have existed 40 million years ago? So, it would have been better for scientists to assume that amber is some kind of young mineraloid. For example, the source of resin for blue Dominican amber was the fossil tree Hymenea protera from the legume family. And when this amber burns, it has a completely different smell. a floral scent. Here's another striking fact. Amber formed in the air and immediately in huge quantities. Since amber contains many inclusions of flying insects, we can confidently say that it formed right in the air. Moreover, there are entire scenes of insect life in amber. For example, a part of an anthill with ants, their eggs, and nearby aphids. Mating of two dipterans. A spider catching its prey. Insects, mosquitoes, and flies at the moment of laying eggs. Parasites, mites on the bodies of other insects, winged termites. For a pair of mosquitoes to end up in resin in a natural pose, the resin had to be released and engulf them instantly. The insects didn't even try to crawl out of this trap. That means they got into the resin in an instant. The volume of resin was large, not just drops. The amount of Baltic amber that is extracted indicates that its formation was a colossal process. The trees produced thousands of tons of resin at once. But then, where did those trees themselves go? Amber also remained in the sand and loam, but the trees themselves disappeared. Let's figure it out. Let's examine amber's chemical makeup. It has elements uncommon in three organic matter: nitrogen, 0.2% sulfur, up to 3% iron, plus calcium, silicon, aluminum, and magnesium. Inside Baltic amber, there are water bubbles and clay inclusions. This indicates that the resin, while still in a liquid state, ended up in water along with these inclusions. Also, Baltic amber has a high ash content, up to 9%, which is quite a lot. Subtitles by Taimyr. In amber, they also find many burnt tree pieces and scorched cones. If the trees burned, then why did the resin survive and turn into amber? By all laws of nature, it should have burned faster than those cones. Often, pieces of amber are surrounded by petrified blue clay. Amber deposits are not connected to coal deposits, and in general, there are a lot of questions about its origin. But if we follow the traditional views in geology that coal deposits originated from layers of trees, then some amount of amber should have been preserved there as well. Coal doesn't contain amber, and amber deposits don't contain coal. Baltic amber is found in blue clay between layers of lignite or on top of them. Lignite is a type of brown coal. It likely formed from silt and peat deposits in swamps. Does that mean all soil with amber was once a swamp, or did standing water remain here for a long time? Now that's the most incredible part. How did inclusions of fish and marine organisms end up in amber? In Baltic amber, they find algae, sponges, starfish, fish, mollusk shells, and even traces of plankton. This suggests that a wave came from the sea, and these representatives of marine fauna ended up in the resin that was falling into the water. However, many of these organisms live on the bottom. It turns out it was a turbulent flow of water or even a mud flow. But then the amber should be cloudy. But that's not the case. There are many freshwater species in the amber. How they got into the amber, the mechanism is unclear. The next incredible fact is the huge pieces of amber. Some pieces of amber weigh 3 kilograms, and there are even pieces weighing up to 9 kilograms, which is nonsense for natural resin secretion. The resin either clumped together into huge pieces, or there were conditions when a lot of resin came out of the trunks. For example, the resin was drawn out by a huge pressure difference. This could have happened if atmospheric pressure dropped due to some global cataclysm, and the pressure inside the trees forced all the resin out. Mystery of how immature amber and copals form. The resinous mass is called Krantzite. This partially hardened resin is found in the same Baltic basin. Interestingly, Krantzite does not contain succinic acid, and its sulfur content reaches 6%. Another distinguishing feature from regular amber is the presence of aromatic compounds. Why this resin, Krantzite, did not polymerize or fossilize is unclear. Types: amber. Fossil copals can be considered relatives of amber. In the Aztec language, copal means incense, but in Russian it is obviously derived from the word kopali. For some reason, this stone, which looks like amber, is not considered amber. That's because it's too young in formation and comes from the resin and sap of legume family trees, specifically Hymenia and Trachalobium plants. They are found in Central and South America, in East Africa, Madagascar, New Africa, Australia, New Zealand, as well as in the Caucasus, Georgia, Armenia, and Azerbaijan. As a result, copal is less durable than amber and often cracks during storage. That's why it is considered not quite real amber. Besides, apart from the Baltic basin, there are unique places with amber deposits. Among them, Taimyr amber stands out. Right away, a question arises. How could amber form in the north? Well, probably only in a subtropical climate. The age of Taimyr amber is estimated to be between 75 and 115 million years. Recently, two families, 30 genera and 57 previously unknown insect species were discovered in Taimyr amber. Here is a fossil ant found in 1987 in Taimyr amber. The area of Taimyr amber deposit stretches across the Arctic zone in the north of Krasnoyarsk Krai, in the southern part of the Taimyr Peninsula. And now, here's the most interesting part. Let's propose a remarkable but real theory about how Baltic amber formed, a theory implied by the amber's own existence. How did it all begin? Some force acts on the trees in the Scandinavian region, splitting them into splinters and causing all the resin to come out of the trunks directly into the air. This was likely caused by a sudden change in atmospheric pressure and exposure to high temperatures. After the resin came out, the entire forest burned, but it didn't burn down completely. The fire lasted for a short time, no longer than half an hour or a few minutes. The temperatures of the fire were high, reaching several hundred degrees, but not thousands, otherwise the resin would have burned up. And so it ended up in the air and trapped the insects right there. As a result of the same jump in atmospheric pressure, a series of sea or ocean waves forms, which move one after another toward the newly formed resin, concentrating on the side of the North Sea. The waves have such kinetic force that they crush and shatter the Scandinavian mountains. As they pass through, they lift earth, capture countless organisms, plants, insects, animals, people, and carry everything into the Baltic. The height and power of the wave are such that fish, plankton, and marine organisms fly through the air. The waves pass through the North Sea, all of Scandinavia and Finland, washing away everything in their path. The resin is covered by a water clay wave mixed with sand. The waves cover the remains of trees, the fire is extinguished instantly, and the resin doesn't have time to burn. The slightly charred trees go out. Along with the resin, the wave washes away the remains of trees and all the organisms that were in the forest or nearby at that moment. The wave carries the accumulated masses from Scandinavia to the area of the Baltic Lake and buries them right on the bottom. All the dead organisms also end up on the lake bed. Here, the wave loses its kinetic energy and no longer carries organic matter. Further on to the Russian north and the Russian plain, huge tectonic faults form on the bottom of the Baltic Sea, from which liquid ore containing iron pours out and it begins to form blue earth. Next, the process of tectonic movement and mountain formation begins, and it pushes some of the resin deposits underground into mountain folds. All these events happened within minutes. The resin shouldn't have had time to burn or be destroyed by changes in atmospheric pressure, otherwise nothing would have worked out. You can see that the wave was enormous, since there were even fish in it. Subtitle editor. This is a diagram for the Baltic. The blue circle indicates the impact in the atmosphere. The light blue highlights the area of a sharp jump in atmospheric pressure and temperature. Green marks the main forest capable of producing resin. Blue arrows show the passage of waves directly through the Scandinavian mountains. The area of impact can safely be moved toward the Atlantic and Iceland by several hundred more kilometers. At that time, Iceland and the Faroe Islands apparently did not even exist. The impact occurred over the ocean. A series of waves broke through the dam between Denmark and Norway, where the strait is now, and turned the freshwater Baltic Lake into a true sea with slightly brackish water, introducing plankton into it. After that, the Baltic turned into a region filled with dirty sludge and remains of organisms for several hundred years. So, some conclusions and assumptions suggest themselves here. In this case, You can't conclude the atmospheric pressure of that time from the pressure inside the amber bubbles. There are assumptions that the pressure back then was 4 times or even 8 times higher, since amber was formed under conditions of an incredible catastrophe, and the pressure inside the amber bubbles could have been either higher or lower. The flora and fauna in the frozen pieces of amber also confirm the fact of a subtropical climate in the northern latitudes up until the 18th century. The large-scale pearl harvesting in the far north during the same era also testifies to this. As is known, creating pearls requires an average year-round temperature of 20 degrees Celsius. For such a huge amount of amber to form, nature at that time must have resembled a tropical jungle, probably with an abundance of giant trees. This supports the theory that Peterburg was not built but rather excavated in the 18th century after this catastrophe and the subsequent rise from under the water. That's exactly why it wasn't destroyed. In this context, the main mechanism behind the formation of Baltic amber becomes quite clear. Such a catastrophe couldn't have been caused by a nuclear explosion, a comet impact, or anything else we can imagine. There could be many theories: a weapon of unimaginable power, or an instant change in the very foundations of nature caused by processes unknown to us. Processes.